For the past several months, the open-weight reasoning standard has been DeepSeek v3.2. It requires 671 billion parameters to achieve its elite mathematical deduction. Then, a team of 9 engineers at the Chinese social media company Sina Weibo released VibeThinker. It has just 3 billion parameters. Yet on the AME 2026 math benchmark, an Olympiad-level test that easily breaks most systems, this tiny model posted an identical score of 94.3. A model 223 times smaller matched the industry giant perfectly. The economic reality of that parity is severe. DeepSeek R1 took an estimated $294,000 to train. Weibo achieved this result with a post-training budget of exactly $7,800. When a 3 billion parameter model posts these kinds of numbers, the machine learning community immediately assumes the test is rigged. The accusations come fast. Either the benchmark questions leaked directly into the training data, or the model was aggressively benchmaxed, tuned to output the exact patterns required to pass the test, at the expense of actual utility. Taking these scores at face value requires us to challenge the scaling laws that have governed artificial intelligence for the last 3 years. The assumption has always been that reasoning requires scale. If the VibeThinker data holds up to scrutiny, we are looking at either a masterclass in benchmark manipulation or a technical proof that reasoning doesn't require massive parameter counts. A close analysis of the empirical data shows the model is neither a fraud nor a giant killer. Instead, it provides a case study for a specific architectural theory. Intelligence is not a single monolithic trait. The capacity for verifiable reasoning can be mathematically decoupled from broad world knowledge. Understanding how Weibo executed the split points to a possible future for AI deployment, one where logic processing is separated from vast, expensive knowledge storage. Before breaking down the architecture, we have to rule out data leakage. If the model memorized the test, the pipeline doesn't matter. We start with Live Code Bench version 6. This tests real-world executable code, forcing the model to write scripts that actually run, rather than just outputting correct syntax. VibeThinker scored an 80.2% pass at 1 rate, comfortably beating GPT 5.2's 79.5%. Live Code Bench is a strong indicator, but the only mathematically absolute defense against memorization is temporal isolation, testing the model on problems that did not exist when it was trained. This is why the LeetCode anti-leakage test is the definitive metric here. We look at the exact date Weibo froze the model's training data. Then, researchers evaluate the model exclusively on a subsequent window of weekly LeetCode contests held weeks after the training cutoff. The sample size for this test is 128 entirely novel algorithmic questions. Because these problems were published after the model was compiled, they physically cannot be in the training set. VibeThinker passed 123 of those 128 unseen questions on its very first attempt. That is a 96.1% success rate on completely novel algorithms, outperforming heavily resourced generalist peers like Claude Opus and GPT 5.2. These results confirm the model's mathematical and algorithmic deduction is empirically real. It is an authentic reasoning engine, navigating logic it has never seen before. That an AIME-level reasoning engine is only half the story. To understand what VibeThinker actually is, we have to look at where it completely breaks down. GPQA Diamond is a benchmark built to test graduate-level science and open-domain factual knowledge. On this test, VibeThinker drops to a mediocre 70.2, creating a massive gap compared to Gemini 3 Pro's 91.9. Move into real-world developer testing, and the blind spots worsen. The model routinely fails to recognize standard Python packaging tools like the UV script. It struggles to write code using heavily documented libraries like Pandas and NumPy. It also entirely lacks API tool calling support, meaning you cannot use it to autonomously orchestrate web searches, file executions, or external software. The resulting system is a genius idiot. It can flawlessly execute complex dynamic programming, but it possesses zero context about the external world it operates inside. So, by what exact mechanism did the Weibo team build this highly specialized, highly isolated logic processor for a budget of just $7,800? The first cost-saving measure was skipping pre-training entirely. They used Alibaba's existing Qwen 2.5 Coder 3B as their raw foundational base. From there, they ran it through a 4-stage post-training pipeline called the spectrum-to-signal principle. Stage 1 is supervised fine-tuning. The second phase aggressively filters data, throwing out reasoning traces shorter than 5,000 tokens, or problems the older 1.5B model can already solve. Discarding easily solved problems forces the model's weights to adapt strictly to complex, long-horizon challenges. Stage 2 applies multi-domain reinforcement learning. They use an algorithm called MGPO, or Max-Ent Guided Policy Optimization. MGPO explicitly hunts for problems that sit exactly on the model's current capability boundary. It ignores questions the model finds trivial and ignores questions that are currently impossible, concentrating all compute on the edge of its logic. They pair this with a secondary mathematical RL stage that redistributes rewards to favor shorter solutions. This forces the model to be accurate without wasting tokens on verbosity. Stage 3 is checkpoint distillation. They extract the successful reasoning trajectories generated during the reinforcement learning phase and feed them back into the model. To prevent redundant training, they calculate a learning potential score based on how perplexed the model is by a specific solution. Distillation only transfers the logical pathways the student hasn't fully mastered yet. Stage 4 locks it in with InstructRL, utilizing rubric-based reward models to enforce final formatting constraints. All 4 of these stages are highly targeted post-training optimizations. There was no brute force data ingestion here. The $7,800 price tag suggests that instilling elite logical deduction is largely a post-training alignment problem. Storing broad factual recall, however, remains an expensive pre-training scale problem. This engineering pipeline perfectly explains the discrepancy between the model's flawless math scores and its limited general knowledge. The Weibo authors formally define this in what they call the parametric compression coverage hypothesis. They argue that verifiable reasoning is a parameter-dense capability. Logic relies on internalizing a finite set of rules. Once you know the rules of algebra, you can deduce infinite answers without needing to memorize the specific numbers. That rulebook can fit inside a compact 3 billion parameter core. Conversely, open domain knowledge is a parameter-expansive capability. Factual recall requires a sprawling network. You cannot deduce the capital of France using an algorithm. You simply have to store the data point. That requires brute force parameter scale. These results indicate that AI capabilities do not share a single scaling law. You don't need a trillion parameters to deduce a sorting algorithm, but you do need them to remember historical dates and software documentation. The implications of this hypothesis align with a new approach to commercial AI infrastructure. This suggests an intelligent hybrid architecture, a departure from the purely monolithic generalist model in favor of specialized clusters. Compact specialized models could handle a significant portion of user logic tasks at the edge with near-zero latency. They would query massive, centralized trillion-parameter models strictly for their encyclopedic knowledge base. VibeThinker-3B doesn't mark the end of giant models. It simply alters their role. Giant models are no longer required for everything. They are now reserved strictly for the tasks that small logic cores cannot compute.